Assalamu alaikum. Okay, so mm, first let's see some basic questions related to circular motion. Then we try to solve theory question also. This is question one. It's the previous section, turning effect of forces.
Sir, will we solve the questions about thinking distance and the
Yes,
stop?
yes. There is a question related to that. I will also, we will solve this question in this class, so that will clear your concept that how questions can be asked about thinking distance and okay, this is from elastic deformation. So friction forces. Yes, so this is the concept. Yes, these are the questions related to the circular one. So observe that all questions are on pattern that boy is sitting on a turntable and it is moving in a circular path. The direction of rotation is mentioned over there, and they are asking about the resultant force on the body. So we discussed that it will be always towards the center of the circle. So the resultant force is in the direction of
Why?
X.
yeah,
Oh.
y
Oh wait, yeah,
towards the
sorry, no.
center, right?
Yeah, yeah, no. Yeah, I
Yes.
forgot.
So questions are situation was they always give a single answer towards the center like this.
So
Question nine
if
is
the
hmm,
if the resultant force is toward like if towards a circle, then why does it the object move closer?
closer means
Like why does it not move towards the circle
okay,
itself?
okay, okay. Because when we try to just start the motion of the circular one or the object, yes. So one force is actually in the outward direction, right? So that force which keeps or which tries to keep the body out of the circle is known as centrifugal, right? But that is not the part of our syllabus. So that's why I not used to write those terms, because that will confuse you sometime that is it centripetal or centrifugal, because this is only limited topic in your syllabus. So that force which actually acts in the opposite direction, so that is the centrifugal, and that force which keeps the body in a circular path and that is towards the center of the circle is known as centripetal, right? A is the answer. It will always towards the center of the circle, right? There are some, because this topic is very applications. There are different equipments that is related to the circular one, but that is the advanced application, right? And if you have other questions, so most of these are like the same pattern, like this. Now airplane is moving in a circular path with a constant speed. In which direction is there a resultant force?
Option D.
D.
Wait.
Yeah, yes.
Yes, because you can just identify with the shape of the airplane that airplane is actually going to move towards left hand side, right? If we
Yeah,
consider our
clockwise.
screen, yes, so it will move like on the left hand side. So it means that resultant force will always towards the center. So that is option D, right? So these are the preferences of that topic. So most ask about the same thing. Yes, this is the
So are those
example of the
mostly
bike.
MCQs?
Yes, because it this topic is very limited, right? Because we are not going to solve the formula, we are not going to solve numerical. So now we left out with only conceptual thing. So that is very simple, right? So in this equation, or sorry, in this diagram, what will be the direction of resultant force?
A.
A.
Yeah,
Capital
same.
A.
Yes.
Yeah.
This is the only force towards the center, right? So these type of questions are included in your worksheet. You may try by yourself also. Now let's try to solve theory questions related to the thinking distance and the all other concepts. Okay, this is the MCQ. There is a question which I found to the thinking distance, stopping distance. We already discussed the concept of moments, momentum, turning effect, mass, weight, and density, motion, spring, right? So these are the topic that we already discussed. So try to solve the questions and ask me anything that you find difficult, because after practicing the question, you will find that which concept is difficult one or which topic you want to revise again. Okay, so the question is, okay, so this is the question. So in this question, the overall distance of the cyclist is made up of two parts. Those two parts are also mentioned in the written form, and it is also clearly mentioned in your diagram, right? So what we need to do actually, in the first part, that is also very simple. State the energy change that occurs during braking. So what type of energy actually produce over there, or what type of energy change takes place over there?
It goes from kinetic energy
Yes,
to, I don't know, heat?
yes.
It goes from
bec-
kinetic energy to
To
potential
the
energy.
thermal,
Thermal energy.
yes,
Yeah,
that
because the
heat
brakes
energy.
produce
When we
heat.
applies the brake,
Oh
so the
yeah.
temperature of the tire increases, right? So that is also included
Oh, like
in
that.
the
Okay.
yes, energy. So
Um,
I'm just
Isn't that
asking.
like a negotiable amount? Like a very tiny amount?
Yes, yes. It is not completely converts into that one, but this is only journal concept. So that's why I asked, because we also need to discuss this concept in detail in next chapter, right? So don't worry about that, about the names of the energy or the type of energy. So if we generally write about the concept, so actually kinetic energy actually changes to right to the thermal energy. We are only writing about only one, because we are not going to explain energy, because our main concern is to solve the distance or the stopping problems, right? So next one is the graph. First take a look at the graph, then we will solve the question that what they are asking in the.
Okay.
Okay, so in this question, there is a situation in which a ball rolls in front of a cyclist, right? Cyclist, and just ball rolls in front of it at time t is equals to 0, and then suddenly cyclist applies brake and comes to rest, right? Just like that, someone is crossing the road and we suddenly applies the brake. So that is the situation. And the graph is of the whole situation is in the next diagram, that is figure 12.2, right? Now let's first see what they are asking in the question, then we try to answer the question. So the first one is, using figure 12.2, determine the reaction time of the cyclist. So what is the reaction time of the cyclist in figure point? You know the reaction time, that is the thinking distance,
Zero
right?
point 0.4 seconds.
0.4.
0.4. And why 0.4? Because all know that
Because he
it will
breaks at
start to
zero
decrease.
point 0.4
Yes.
and starts from 0.
Yes. So before that, it is actually moving with constant speed because there is a clear road.
Yeah.
After this specific point, it starts to apply brake, and this is the thinking distance, because at 0.4 seconds we start to think and we start to react, right? And it will take time to completely comes to the rest state. So this is the which is related to the thinking distance, right, or the reaction time. So 0.4 second is your reaction time. And the next part,
Sir, how is the reaction time different from the thinking distance?
Actually, thinking distance is
Ah,
related
okay, okay. We just
to, so
list the
that is
distance.
distance. Yes.
Ah, okay,
So
okay,
that is
okay,
only
okay.
the difference.
Sorry, sorry.
And now we need to calculate the thinking distance, right? So we just find out the value of time, because to calculate the thinking distance, we used to apply the same formula for the distance or speed. So distance can be
Yes.
calculated s equals to vt, right?
Yeah.
Because v is equals to s over t. So what is the value of speed at 0.4 seconds?
Wait, can you go up? It's 7
7.
7.
meter per second.
Yes. So 7 meter per second is 0.4 seconds is the time. So this is the value of the distance of the thinking distance, right?
2.4?
2.4, okay.
No, wait. No, sorry. 2.8. 2.8, I think. Yeah, it's 2.8.
Okay. The next part is the theoretical one. State how the braking distance is found using 12.2. So they are asking about braking distance, right? Previously, in previous two parts, we solved about thinking distance. Now they are asking about the braking distance. So how we can find out the braking from 12.2? That is also simple.
It's like the
Hmm.
part where the speed is decreasing,
Okay. And after that,
like the area under that triangle.
area under the triangle. So that is the simple concept. Yes.
Yeah.
So this is the line and this is the part from which the speed is actually decreasing to the zero. So that triangle shows
8.
you the total distance, right? So, okay, you already calculate 8. Okay, so
Wait,
let's,
no, no. Wait, no, not 8. What am I doing? Sorry.
okay. Okay, first of all, we need to
It's
write it. So
7.
that is simple. So you just need to write area under the curve.
Curve a triangle.
Actually, we use the journal term curve. We are not writing about that specific triangle. Curve means it may be any line, and we need to just cover and find out the area of that graph or that curve or that rectangle, triangle, anything. So area under the curve is just a single statement or journal term, right? For this concept.
Okay.
So you just need, so that's we are not to explain that one. And the next part is, on another occasion, the same cyclist travels at the initial speed of 5 meter per second. So now the important thing is the same cyclist, but it is moving with meter per second. A ball rolls in front of the cycle at time t is equals to 0. Again, same scenario, right? The cyclist has the same reaction, that is 0.4 second, and the deceleration of the cycle is same as in figure 12.2. Okay. So now there is only one difference in the question, is the difference of speed. Otherwise, all scenario is the same one as the previous, right? So actually what we need to do for 2 mark, you need to draw a new graph, new speed time graph for the cyclist on that same graph, right? Only you need to remember that speed is 5. Otherwise, all situation remains the same. So we need to draw a straight line for 5 seconds, 5 meter per second. So 1, 2, 3, 4, 5. Okay. This will be our reaction time at this point, right? And after that, we need to just draw a straight line till 0. Okay. Got the concept?
Yes,
Yes,
sir.
sir.
Okay, there is, you just need to draw a straight line. So it will be a straight line just moving towards the 0. So that is the question they are asking in this part. So you just need the same line on that same graph 12.2. Okay. Now what they are asking in the next part. Okay. Now this is the conceptual. The braking distance is longer when the cyclist stops on a wet road. So this is also a very journal and very simple concept. I think that is not much difficult. So actually when the question is for 3 marks, so you need to mention all the forces that are involved in this process, all the possible action reaction forces, all the possible direction, all the possible factors. So you need to explain with reference of braking distance, right? So first of all, we know that on a wet road, what was the first concept related to the force that comes into your mind? That is related to
Mm.
the friction, right?
Yeah, reduced friction.
Yes. Or we can say that friction will be like negligible, right? It is almost equal to zero, but not completely almost zero. It will be like negligible friction, right? So first of all, you need to explain about friction.
There will be less friction.
Yes. And what are the other factors, or how we explain the braking distance is longer? Why braking distance is longer? Okay, one more thing, because there is a graph in the question. So in this type of question, you may also take the reference with the reference of the graph. You may also explain in terms of graph also, right? Let's suppose if we take the reference from the graph, so it will take more time to stop, right? Because in this question the cyclist stop after a short interval of time, right? But on a wet road it will take more time. When the cyclist take more time, so your gradient of the graph will be more steeper or less steeper?
Less deeper.
Less steeper. So in this type of question, try to take or try to find out the points related to the diagram or related to the graph, right? So we can also say that the gradient of the graph
But so that doesn't explain why.
actually you may also explain with the reference that the gradient of the graph will be more steeper because it will take more time to stop a vehicle on a wet road, right? Because you just write the scientific term gradient of the graph. So gradient of the graph is steeper or itself is a complete concept, right? So we are not going to
Okay.
explain that complete concept, right?
Okay.
Sorry, less steeper. Any other point that you need wants to mention?
No, I don't have it.
Okay, in the factors of the braking distance, we discussed that the wet road or the condition of the road is also a situation, or we can say that it is also a factor that increase the braking distance, right? So you may also just write that reference that braking distance actually depends upon the condition of the road. So if we are having a slippery or a wet road, so braking distance will be greater, right? Because that is a general factor on which the braking distance actually depends, right? And you may also write then when a driver or when object or when cyclist applies brake, because they are asking about the cyclist. So when cyclist applies brake, so the cycle will skid over the road, or it will just drag over the road to comes into rest state, because there is a wet road surface, so friction will be less, right? So you may just phrase this question in a detail one, because I just write a small short point for the first one, and we have second point with the detail. And you may also say that because we mentioned two things in a same point, that the gradient of the graph will be less steeper, right? And the second thing, it will take more time, or your graph, if we talk about the graph, so there will be a large distance on the graph on x-axis, because time will increase, right? Or we can also mention one more point, that your thinking distance will also be change in that situation, because we know there is a wet road, so we think just before, or we just think immediately to apply the brake, because we know it will take time to just come into red or rest on a wet surface, right? So these are questions, and these type of questions are actually loaded in your exam. This is also the same part from that question, but it is actually related to the pressure. So we just skip this. So there are more questions in this worksheet for that friction and braking distance, thinking distance, circular path. So you may try by yourself and let me know if you find anything difficult, right?